First of all, it's been a great event. I think that with such diversity of new technologies, it's really important to benchmark and ensure quality across new designs and with new materials. And so the heavy focus on new technologies and new materials that are deployed in those new technologies is quite useful for me. A lot of it was interesting. I liked Ryzen's talk on the risks of some new technologies as well as technical roadmaps, particularly as it relates to heterojunction and longer-term tandem devices. I mean, it's exciting that the big players are now talking about these new innovative technologies that have been around for many years, right? It's kind of always been a topic of discussion, but now it looks like a lot of these exciting technologies are becoming more real for the mainstream, and that's very exciting for us. That's a big challenge, I think, for the industry as a whole, in particular buyers and third-party quality assessors. At Henkel, we're really a global leader in electrically conductive adhesives, which are used in various new module technologies, but quality of that material is not well understood in the industry, and the impacts of that quality control at the ECA supplier site really aren't covered in the testing that I see today. So specifically about Henkel's business, it's certainly an area where we can improve, and there's some discussion on IEC standardization talks for new module designs that utilize ECA, and I think that that's needed. Yeah, absolutely. I mean, and a lot of the focus is on kind of ongoing third-party quality engineering audits, right, during production for the buyers. And again, I'll go back to low-temperature materials, which Henkel has an expertise in. That's specifically important because when you're starting to talk about advanced materials, even when you're looking at multi-bus bar of advanced cell types, you're looking at tighter process windows. And so it's no longer buying as much of a widget. It's more of a reactive or a tighter process window required materials that have been traditionally used in other industries, and that becomes super important to ensure that you don't have failures in the field. Sure. Yeah. I mean, it poses a lot of risks, right? When you don't have enough data set on your new materials that you're deploying, or really even new designs, right? You're really pushing the boundaries of your process. You're really not going to understand it well enough. So I think working with reliable partners with a long history of experience is needed, first of all, but second of all, we need the kind of upfront investment and quality focus, to instill the confidence in the buyer and in the investor market for new technologies. Yeah, of course, bifacial makes more sense on paper for utility scale, where you've got trackers, ground mounted, and you can control, maximize bifaciality more. But to be honest, I think that when you look at the cost of producing bifacial cells and modules, it's really getting very close to monofacial. So if I could make a projection, I would think, in the future, they might all end up being bifacial just by virtue of cost versus value when you look at the scale of manufacturing cells. Yeah, there's a lot of new technologies trying to make modules with higher power density, make more efficient modules to reduce your LCOE and your soft costs and so forth. I think that there's obvious advantages for half-cut cell, multi-bus bar. Then with tighter packing, you look at shingling. That's also an interesting technology. And then the various new technologies coming out in China, tiling, paving, fitting more watts into the module footprint is an obvious path forward. I think when looking at those technologies, we really need to look at what's actually able to cope with the quality standards. And you know, I saw it with shingling as an ECA supplier. You get a lot of people promoting a technology that don't actually produce it. That's a risk for jumping into new technologies too quick. Yeah, I mean, I think Europe is really looking seriously into introducing you know, gigawatt level heterojunction production and developing a local industry for cell and module manufacturing. I think, yeah, maybe not next year to answer your question, but in the coming years, I think there's going to be kind of a relocalization of manufacturing footprints, especially for greenfield sites. As panels become so cheap, you're looking at transportation costs that are expensive, and then really a less of a barrier of entry in terms of CapEx to build capacity locally where it's consumed. So I think, honestly, in the long run, there's going to be a diversity of manufacturing base for modules for sure, and perhaps cells as well.